So today we're going to talk about AI ops and what AI ops is. So AI ops is actually a term that was basically created by Gartner. Then I'll get to the slide on that. But basically AI ops is a term that's used for applying machine learning, automated intelligence, applying basically some rules and intelligence to big data sets to derive root cause analysis and attempt to resolve certain issues. So the whole point of it is to mitigate. In this context, there's 8 billion different ways you could go with this conversation, but specifically for this discussion, we're going to be applying the AI ops terminology specific to ITOM. AI ops is leveraged a lot across the platform, but in this presentation, we're going to speak specifically to ITOM: events, correlation, metrics, remediation, and how it could help clients resolve issues. So what we've been seeing as companies grow and grow, IT resources from both a compute, infrastructure, personnel, and demand is always growing. Companies never get smaller. They're always being asked to do more with less. So as companies mature, what happens is they hit that ceiling where they hit the threshold where I now cannot do what is required with the resources that I have. And they might not even realize they have a problem until it's too late. So they could be running fine. They don't know that there's an issue, but the issue could be occurring. They don't know it until something happens. And that's always the case when it comes to any one of these issues that you always see in the news, where an outage occurs. And what happens is when an outage occurs, they attempt to do that whole, all right, triage. Let's try to understand what's going on. They try to correlate and figure out, okay, what happened? What did it impact? All right, network's down. What switch is connected to that network, or who has ownership, or what's connected to that? What has it impacted? You really don't know that until you try to actually collect the information from the various people who have that information and try to build a context around it and define a root cause analysis. It's very difficult to do when you don't have the systems in place to help figure out exactly and do that correlation. So these companies, your AWS, even Netflix, actually, I don't know if you guys saw this in the news, but I think it was some European country actually reached out to Netflix and asked them to turn down their streaming services because their internet is breaking because of the virus that's going around right now. A lot of people are saying from home working, which is putting all their resources are completely constrained. So their internet is actually breaking. This might help realize what part of the infrastructure could potentially be breaking and add more resources from a network perspective. Things like that. This whole process of what is status quo. I lived this for many years where something goes down, I have no idea what is impacted. You start getting angry calls from clients, customers, end users, application owners, trying to figure out why they can't access PeopleSoft or why they can't access a certain portal, access a map drive. Something happened, I don't know what. Try to do that correlation, try to figure out who owns what. It's impossible to do. As I stated already, so AI ops combines big data and machine learning to support the whole IT operations functions. So leveraging all of the different tools and tools, that's air quotes there, that clients have. And as you guys know, clients have many different disparate tools. When it comes to event management, for example, when you're talking event management with a client, they will have 5, 6, 10 different event management platforms, depending on the group that owns that piece of infrastructure. Sometimes large organizations will have their own homegrown application, which takes all of their disparate event management tools. There could be 30 or 40, and they will collate those event management tools into a single source so that we, from a ServiceNow perspective, can ingest it. So that is taking all of that data and ingesting it is good. We'll have that data. The trick is applying the machine learning and intelligence behind it to be able to deliver some value to the customer. If you look at the platform within IT and take a look at the whole process of request, prioritize. So the whole process from start to finish, where the end user is requesting something, we have to make it happen. If we're on the operations side, there's a gap there. So what we're trying to do is bridge that gap and mitigate it so there's transparency from what that piece of hardware is and what the service to the end user is. And we could see that whole correlation from what is impacted, connectivity, the metrics that we're gathering, and drive value. Basically, we're trying to make the easy button. So the whole AIOps solution from a ServiceNow ITOM perspective takes all of these different disparate things that ServiceNow has been doing. So ServiceNow had recently, a couple of years ago, acquired a company called Continuum. They do predictive intelligence. There's a couple other companies that they purchased and some very intelligent people that have joined their company that have started to make this a reality. So a couple of years ago, started taking in metrics so we could collect metrics from different sources. So those metrics are truly just IOPS per second, CPU utilization. And we're taking that in. And once we take that in from all these different sources, the different CIs, network infrastructure, things of that nature, have all those metrics. We're collecting those, taking a look at historical data, looking for anomalies. Once we get the alerts in and the events in, and if we know about the applications, what's connected to what, how the business services are actually mapped and what the relationship is between them, we can actually derive and make some intelligent decisions. Kind of what I alluded to earlier was the transparency. So you have your services oriented model, and then you have your IT model, and they very rarely map well together, right? Because we don't know what's connected to what. Operations guy knows that he has a storage array, there's no amber lights, the storage array is running fine, not a problem. If a disk fails, what does that impact? Who knows? Well, you'll find out eventually when someone calls up and says, hey, I can't order something in a catalog. Why is that? Because I can't connect to X because something is down. So the trick is taking some of the predictive analytics, applying AI ops to this with what ServiceNow has to offer. You have the ability and visibility to both act in a reactive state. So if an event, an alert comes in, you can remediate it almost immediately, or using predictive analytics, you could actually be proactive with alerts stating, hey, there's a 85% chance that in the next 4 hours, this Oracle instance is going to go down. And it knows that because the last 3 weeks in a row, at roughly the exact same time, it has seen 2 or 3 different things happen from an event management perspective in a pattern. So using the patterns and using the historical data and the analytics and applying that knowledge, you could actually be proactive, which is kind of cool.
Does that mean like you would have a configuration item for a disk mount, like every service and share, and they would all be called out as a dependency stack for every application, every service, every component in the system, so that you can do that predictive analytic?
Yeah, because you know that disk, let's take an EMC storage array. Every disk has a disk unique identifier. So if we go do discovery, right, we get all that information, we'll have that unique identifier. If an event comes in from the SMIS connection by discovery from the EMC array, that we discover that, we have that information, event comes in, we already know based on discovery that disk unique identifier is in that EMC array. That disk is attached to this fiber channel port, which connects to this server, which has this application, so it draws all of that. It knows about all that stuff. So it will be able to draw that correlation. And I can show you that if we have time.
I don't want to slow everything down.
But I'm actually, yeah, so that's a good question. And what I can do, we should have enough time where I have a demo where I could actually show you how it all cohesively comes together and actually makes sense. So the whole point of this is an end-to-end solution. So the ability to give you insight into everything that you have in your environment. So you can see the operations, software, hardware, connectivity, relationships, the health. So we have with the application services, we're collecting metrics, right? We know about events that are going on. We have the event management dashboard. We can truly see how your services are actually running. And then the optimization, you can optimize your spend financially, optimization both from a software spend and resource. So you could actually optimize your resources based on utilization. If you're collecting these metrics, you can gain some insight into where your resources are being spent as well. So that gives you the ability to make operational you could actually make operational decisions in the context of your business services. So if you see a critical alert come in, if I'm an alerts, if I'm overnight operations guy, my whole job is to make sure nothing catches fire, and do, nightly backups, things of that nature. But if an event comes in and I see an alert, a critical alert, I freak out. All I see is critical alert, big red thing, and that could apply to a business service that is not very critical. And then right after that alert, you'll see an alert that it's not critical. It could be a little less than critical, somewhat critical, but it could be applied to a business service that is critical. So the priorities would change based on the business service priority. I'll show you that in the demo as well. So you can make intelligent decisions on the alerts and what you want to react to based on how critical that business service is. The whole point of this is the ability to keep your business services running as optimally as possible with no outages. Keep your 5 nines available. You want your availability to be 5 minutes or less per service per year. Was it 4 nines or 5 nines, whatever that metric is, but it's 5 or 8 minutes a year. The whole point is to make sure that the business services are healthy. Services are healthy, business is running good, everybody's happy. The trick is, as I stated before, is just the growth of the infrastructure of what the business needs in order to keep functional. It's very difficult to do, and it's getting more difficult with all the different platforms in place. So the ability to ingest all this information from your events, your metrics, your applications, and applying the secret sauce to it and making it something consumable to the end user, that is what this is. Here's an example of AI ops, taking that information in from different sources from an event perspective, and we can ingest anything written to the event _EM table and apply rules to it. So the event source can be anything, truly. You could, as long as you could tie into the API, spit some data, as long as you have the credentials to spit the data to the instance, it will get processed once it hits that events EM table and run through this whole process. So we can take information and metrics from all the different software event management platforms that you see on the left, either by a push or pull, take those events in and do the deduplication, the correlation, the grouping, apply a lot of the AI ops functionality, historical trending analysis to all those metrics, and make something of it and be able to show something's going to go down, something has gone down. And there's 4 different machine learning that are machine learning types that have been implemented. You have your human-defined correlation, as you can see here, temporal analysis, topological, and semi-supervised learning. So an example of temporal analysis would be this. This is an aggregation of events in a timeline from left to right. As you can see here, we'll start grouping based on historical data and do anomaly detection. It will do anomaly detection based on repeating patterns, groupings, and that's where it starts to learn, all right, I start to see patterns now. And that's kind of where the predictive analytics comes in. And then this right here would be the whole structural relationship. So using machine learning, it'll do the topological analysis and know what's connected to what. And it will actually even take, for example, some of the nodes, like the clusters that you see here. So these clusters, it knows that they're clustered and it knows how to treat them. So the clusters and the load balancers, it knows about how they work. So it could truly show a root cause analysis of what is happening. So it knows about the relationships and the CIs, knows what services are running, what services depend on what, and truly determine what caused this downstream issue. And the whole point is to give you this one little view with the red, the green, the orange. All that makes the easy button. This right here is all the stuff that I've already been talking about. That's kind of a summary slide. So the events coming in, the event noise, the deduplication of those events from different sources, the event normalization to help correlate and group those, help reduce, I've seen 99, anywhere between 90 and 99 event noise reduction. So you don't have to go through all of the events and miss some, which is what happened at, I think was it Target a couple of 3-4 years ago, when they had their point of sale platform compromised from a security breach. they actually knew about it, but they didn't know they knew about it till weeks after it happened because they didn't have the ability to go through the event log and see it because they just missed it because it was stuck in the noise. They just didn't realize it. They knew it, but they didn't know they knew it. That kind of mitigates a lot of that.
So it will filter out the consequences to the root cause behavior?
So it will deduce and know that if you get an event that came in from SCOM, so you're ingesting events from SCOM, and SCOM is reporting high CPU utilization or let's say network down or a network interface down on 2 CIs, and there's a Cisco switch goes down and HPOMI is doing event management as well. HPOMI sends us that event that, hey, this switch is down. And since we knew about those 2 CIs where the network interface is down, the network interface isn't down, the network's down, but we got an alert that the network interface is down and we know that that switch is down. We know that the root cause analysis is that switch. So don't go trying to fix the 2 VMs that have the network interface down. It's not that, it's the network switch. So we will show that the root cause analysis is fix the network switch. That's what the issue is. What does this mean? This is my last fun slide. Reduce the MTTR, an example of that, which I will show here in the demo. The ability to fix widespread performance issues. Since we're collecting the metrics, we can see performance issues in your environment. Anomaly detection. So anomaly detection will note variances based on things that are going on in the environment. And anomaly detection is smart enough to know that if you're scheduled outage to do an upgrade, platform knows about the upgrade since we note, all right, we're going to upgrade this operating system. And if we show that once that, the upgrade has happened, we noticed an increase in CPU by like 5 or 10%, it will adjust for that because it knows that we modified the software or hardware to that CI since we took that planned downtime, and it will flag that as an anomaly because the performance or metrics have changed because we changed the actual CI. So it will readjust its anomaly detection baseline based on the fact that we changed the CI. But it's really intelligent. Automated remediation. So there you could put rules in place using orchestration and create rules to say if X and Y happen, do Z. And I'll show you that as well. So based on if we see an event come in, critical alert, if the alert meets the specific criteria, do something. And I'll demo that in a minute. So there's natural language driven smart searches. So the ability to actually, if someone submits a ticket and says, hey, my hardware is broken, I can't do something. If there's multiple tickets that are open for the same problem, even though if the description in that ticket might be a little bit different or the wording, the language normalization will normalize that and kind of draw context out of what was written in the tickets. When you do searches, it will actually normalize that. And so when you do a search, it will apply the contextual information that it gathered or derived from those tickets, and you'll be able to search on that derived information. And then reduce noise and network dependencies. So the whole point of that is if you do a visual, if you're actually to draw out the topography of an infrastructure, of a large infrastructure, drawing out and showing the network dependencies is very resource intensive. So what it does is it will, based on what you're looking at or inquiring about, when it comes to the network topology, it will only draw out and show what the network dependencies are a few hops away. It won't confuse people when they're trying to show something in service mapping or display it or derive information from it. It mitigates a lot of that to help find what's going on from a network topology or anything that the CI relies on the network. It makes it a lot easier to navigate. And that's it for the slide portion. And I know that was a lot of information.
When you're talking about the push and pull earlier, have you seen kind of out in the field more people using the connectors, like the pull technique? Or are most people still using a push where they're setting up a REST configuration? Or
what I see in the field is usually a few steps behind what's being offered in the marketplace. So some of the newer technologies from a connector perspective, I haven't done a lot of that recently. It's usually tied into API, a direct API, and is pushed or actually no, is pulled POLLED, which is pulled PULLED, every 5 minutes or every 10 minutes. It all depends on the events and how many there are, because you have to take that into consideration is the amount of events that you take in could significantly impact your instance. Because if you start throwing, 10,000 events in every 5 minutes, you're just going to kill your platform. So anytime you start talking about events and ingesting events, the first thing you want to do is make sure that you're only pulling events in that are meaningful. Don't just throw all events from whatever the event management platforms are. Just don't throw all of them at the instance. It's gonna die. You'll just take it down.
Is the database the weak link there, or is it the application servers?
So usually, like in any event management system, there's a lot of noise. So you got to kind of think of it as got to filter it a couple times. Filter it talk to the application owner, when I say application owner, whoever owns the event management software in your client. So you'll always have the guy who's responsible for BMC and HPOMI. And then you'll have another guy who's responsible for Splunk, right? So you got to talk to those guys and figure out what events they're collecting, if any of them pertain to what you're interested in. Because some of them could be desktop. You don't care about desktop, so you don't want to ingest that. So you got to clear that out and basically cherry pick what events you want to ingest into ServiceNow. And then in the ServiceNow side, what you want to do is create intelligent business rules, event rules, and that will filter out a large percentage of those that make it from event to alert. And then on the alert side, there's some other things you have to take into consideration, and is how you want that alert to be processed or run.
Does it support, and I'm sure it does, I'm trying to visualize how it would happen, the deduplication at the ingest, say it's Splunk and it deduplicates events. Does it pass the deduplication data into ServiceNow?
Yeah, so the deduplication happens on the ServiceNow side. So
So it would expect an unfiltered stream from Splunk?
Yeah, so when we ingest, and I'm talking about the ServiceNow side, right? When we ingest the data, all we know is apply rules to it, figure out what it is and apply a rule. So if we were to take a look at the event rules and how the events came in, we should answer a lot of questions. So let's take a look at the alerts console. So when an event comes in, right, this is the information that we get. So when it's written to this information is what is written to the event EM table. So when we get events coming in, so I'm going to demonstrate for you how this works. I know I'm going a little bit sideways, but it might help. So anyway, so what I was going to show you was there's an application called Postman. I don't know if you guys have ever used it. Postman allows you to post via API code to an application. So using Postman, I can actually send an event in a flat file form, the code directly to the instance, and it would process it. So the event would be the source. So the source would be wherever you got the information from, which would be HPOMI. Description would be whatever the platform, the application or platform that you're ingesting the event from. This would be basically anything that would be of value to help troubleshoot. The type is the metric, where it came from, and the message key and metric name. So based on that, that's all we get, right? So we know where it came from, what CI potentially, and we can derive the CI out of that event and then process the event and know what CI, if it pertains to a CI, what that event and CI correlation is. What we'll do is we can actually correlate those events or alerts, and it's done automatically in the instance, and it will derive that information. So if we take a look at all the events that came in, here's one, source EM self-monitoring, and this is one that's done by the instance itself. So the instance itself will generate events for itself. So if a mid server is down, here you go, boom, user mid associated with one down mid server. The instance will actually create its own events and alerts, and you can actually apply those as well. So if your mid server is down, you could actually take action upon it. But if you take a look at the alerts that come in, right? So an event comes in, the event rules are in place to say if it meets or exceeds this criteria, create an alert and then run with the alert rules. So as you can see here, here's the source and the resource. So that's disk 2. And we take in all this information. What do you do with it? Because this really doesn't help me at all troubleshoot. All I have is a lot of alerts. So if you take a look at the alerts console, you could actually, you could click on correlated, all right? And it correlated the group, CMDB. And underneath this, it's correlated because they all have to do with the same issue. Even though it received 2 different alerts from SCOM, on one's for Apache 6, one's for iPlanet, and iPlanet runs on Apache. We know about that because we did the mapping. We know about this because of discovery. So knowing about those relationships, we know that it's the exact same issue. So we group them together. And you could actually show a timeline. You could actually see some really cool stuff going on if I had a lot of activity here, but I don't.
If you have a lot of inputs, does it give you a filterable view so that you can?
Oh yeah. Yeah. It is it's really cool. But you could actually drag down and go in deeper and deeper into. So, I just clicked on that star and it brought up that, which we have highlighted down here. But if there were more, you would be able to drill down into it and then zoom in a little bit closer.
One of the coolest interfaces I've seen is the Datadog one, where you have a filter stack on the left and the drag timeline at the top, like you just showed.
Oh, really?
Yeah, and it makes it so easy to problem resolution.
Yep. Yeah, and I think that's what we're going with here. There's a lot of different ways to look at this data. So what is usually done is if I'm Naomi Knock, right? So that's me, Naomi Knock. This is usually where they'll work. So this is the operator workspace. So this takes all of that stuff that I've been talking about and puts it into one dashboard. So you can actually go into, so let's take a look at this issue here. All of these services. So we have your services. They could be grouped by severity, right? So that's minor. All this is minor, but if it's business criticality, it's going to be a little bit different because these are more business critical. So you're going to want to attack these first. And let's take a look at primary alert. Top alert is concurrency limits exceeded. If we take a look at that, priority urgent actions, you could actually, if you have orchestration in place and you feel you're confident, you do this all the time and you know exactly what the problem is, boom, let's just remediate and restart it. You could actually take a look at your secondary alerts. So these are alerts that this was derived from. Impacted services. And let's refresh this, because sometimes when you pull this up, it's not going to automatically determine what downstream has been impacted. So by hitting that, that'll refresh this and draw and figure out what the correlated business services and related CIs are for this specific alert. So you can see all the impacted services, remediation tasks, alert executions. This is the cool stuff. If there was anything cool going on right here, rule-based remediation based on the alert. So automation can be done here. So I have an example. So this alert Let's refresh the install base. Open this in Workspace. So, boom, priority high, critical severity, detailed impacted services, nothing here. Oh, but look at that. Here's a management rule. Handle hardware disk anomaly alerts. What does it do? It will auto expand the disk. Look at that. That's what it did. Executed it, automatically executed that process. So what it did was it actually expanded the disk based on this. So if anytime you see a metric that says low disk, let's run this rule, which will auto expand the disk. So you don't have to do anything. It's just going to auto expand. That's a cool little thing that they've got going on here. So that can obviously be applied to anything. Restart a service, alert somebody, but automated remediation based on the alerts.
How complex can the rules be for like auto expand and
as complex as you want, but you can do anything you want. I mean, that's the problem. you could do anything you want. So it could kick off anything. It's orchestration. So you could apply any rule, any script, anything that gets triggered. So unfortunately, the answer is it's orchestration. So you could have it do anything you want based on predefined metrics.
And you can use rules like how much it costs and stuff like that, or triggered workflows that say go spend some money.
Yeah, you could trigger any workflow. It's very powerful. That's kind of AI ops. The AI ops from an ITOM perspective, how AI ops in the ITOM world can help a client, help a business. Well, the secret sauce underneath and all the different fun things that ITOM has to offer kind of wrapped up underneath the AI ops umbrella. Thank you for your time.